Hello and welcome to our first video for Statistics 2. I thought I'd start us off by introducing the big topic we're going to begin with before you get into your chapters so that you'll have a little bit of an idea of the big picture. I suggest you revisit this video once you've become a little bit more familiar and move further on in the course and need a little bit of review, or if you're having a hard time seeing what the big ideas are. So what I'm going to talk about in this video is inference. So it's going to be very introductory and yet somehow have a little depth to it. So I'm hoping this goes well. So I thought I'd start with what on earth is inference? So I'm going to draw you a picture here. The idea is that you may have a big group of people that you want to know some information about. Now we call this big group of interest the population. I'm sorry I'm using cursive, but sometimes if I let the pen up, it switches to the next screen, which is great. Okay, big group of people, want to know something about them. So what might I want to know about them? I might want to know, like, I don't know, maybe this is my customers and I want to know their average age. I'm going to use mu for this, which is the symbol for mean of the population, just in case you forgot. Or maybe I want to know, like, what proportion maybe of my customers that use coupons. We're seeing that the pen works great sometimes. Proportions, we use a little p. Now, I'm hoping you remember that these symbols are just placeholders. Like variables, they have specific meaning. And here, my mu is representing the average age of my customers. My p, my proportion, is proportion that use coupons. And mu and p are very typical parameters. Parameters are numbers that describe a population. Parameters in general are super hard to get. You either have to sample the whole population, which would be doing a census, or you give up because it's impossible to do. Often cost is a factor here. If you have a huge population, surveying all of them is costly. So more often than not, we don't do this, either because of difficulty or cost. So what do we do? Well, in Stat 1, you should have learned about something called sampling. Ooh, lost part of my pen. There we go. My fortune cookie shapes are doing a good job. I don't know, they're kind of like beans or potatoes. So here's my sample. So I'm being very suggestive in how I'm writing this, because I'm trying to make my shapes look the same. Because if you sample, and sample well, woohoo! Your sample should look like the population. So if you're unfamiliar with sampling techniques or how to sample well, you should go look at some of the Chapter 8 review material. But the basic idea is that as long as you have something randomizing your sample so you can even out the variability amongst your groups, or non-group, just your population, or sorry, not your population, your sample, my apologies, then you should have a good sample. I'm sorry I just boiled down to a whole chapter to one word, but the gist of it is random is good. Yay, random. Okay, so what do I do in a sample? Well, I instead gather those same pieces of information. So I gather a sample mean, or I gather a sample p, and these, if you remember, are called statistics. Statistics are numerical describers of a sample instead of the population. So statistics is an unusual class in the fact that you actually learn what a statistic is in statistics class. So similar, so interesting. So what's going on here? So as you look at this, keep in mind stuff coming off a sample is usually used lowercase letters or stuff with hats on it. So put your hat on to do statistics is a terrible math joke that I used to use for this. But if you're dealing with parameters, we either use capital letters, little letters with no hats or anything adorning it, so to speak, or we use Greek letters. So look forward to that when we start getting into B's and betas and rhos and R's. So why do we do this? I've got sample information. I don't have population information. Well, the idea is that we're going to use inference to complete this circle. Inference is all about there's supposed to be a C in there. You get the idea. It's all about how can I take sample information and use it to estimate parameters. So I'm going to take statistics, and then I'm going to use inference to estimate parameters well. And there will be certain things I need to have happen in order to be able to get a parameter and to do a good job at estimating my parameter. And sometimes it's going to be very difficult. And it's not just estimating we're going to do. We're also going to be able to use this to do, I've lost pennage. There we go. You're supposed to be able to ink anywhere. It's really working well. You're also going to be able to, I can't get this to work. Come on. Pen on. We're also going to be able to use this to do some what's called predictions. So predicting and estimating, those are our two big goals off of Inference. Those are the two big things we get. And most of our predicting is going to be when we start doing linear regression. And I'm going to treat linear regression like a second topic because our big themes for the class are going to be inference and then regression. Because regression sort of melds in with inference and flows off of it well. Right now you should know some basics of linear regression, but you don't know the big story. That's coming. That's what we're going to get up to in Stats 2. So, to give you a little bit of outline of what we're going to do in all of Inference, I'm going to give you a very intimidating slide. So here's the idea. Hey, there's each chapter on here. Woohoo! So as you look at all these chapters, I've summarized what they all are and what the new ideas are in them. The idea is that each of these chapters is going to build on the next with one new idea. So chapter 9 seems large and intimidating, has the most new ideas, because everything afterward is going to build upon it. So although as you look at like chapter 11, where the only new idea is supposedly the T-model, well, it's not really the new idea that's going to be there. We're going to be using all of this stuff to go forward as we pursued our way through this. So as you look at these first, how many is that, 5? All the way up to 14, those are all about sampling. And then when you hit 15 and 17, we're going to be looking at regression or building models off of the idea of inference. And then we're going to do inference for regression or testing to see if our regression model actually tells us anything. So the idea is we build up testing ideas and then we use them to test other things. All right. Next slide. So how are we going to get around this? So these are our big 4 ideas of how to approach the course or what the course is going to teach you how to do. It's going to teach you how to communicate well. So usually you might have been told statistics is just like, go calculate something and then that's it. Well, we're going to get a little more in depth with that. We're going to go through the plan, do, report approach, which is I make a plan, I perform my plan, I report on my results. This is going to be very typical for what all of our inference question is going to be. And it's really the heart of statistics. I wrote that right there, but I can't emphasize it enough. It's really the heart of statistics. And then we're going to do some model building, which is like, hey, how likely is it that my model tells me a good story? Or how can I take this data and, do something with the trend or the shape that I'm seeing in a good way? So you're real used to linear. We're going to encounter some things that are other than linear. And we're also going to talk about what to do when you want to use more than one variable because one wasn't enough. All right. And this third condition I've got on here, well, these aren't really conditions. I said condition because it's got condition in it, is talking about assumptions and conditions. One of the big complaints I get from employers is that when students approach doing statistical methods, they have a tendency to just do things without checking to see if they should. So we're going to treat this like Jurassic Park, which is my terrible analogy for this. Just because you can doesn't, sorry. Don't get wrapped up with whether or not you can, focus on whether or not you should. Because if you shouldn't be using something to try to estimate a value, you're probably not getting a good estimation. It's not going to be a good thing. All right, and then we're going to talk about statistical significance. This is going to be the big end all to be all. Okay, what do I mean by statistical significance? You may look at two numbers and say, ooh, they're close together. That's good enough. Or, ooh, this is far apart because they're $10 away from each other. But $10 might be enough to be just caused by random chance or just a little bit of fluctuation or variation in your values. It might not actually be significant at all. They might be close enough to where, that means nothing. So you might be looking at like average cost or average amount spent at a store as being like $46, and then you get a check back and it's like $20 and you ask yourself, oh my gosh, those are so far apart, that makes a big difference. Yeah, but what if your standard deviation is $30? Oh no, that means it's less than one standard deviation away from the mean, which means they are actually really close. So don't think that just because they are different, that difference matters. We're going to talk a lot about this when we do difference testing. Okay. Whew, that was longer than I intended to be. I'm hoping you get an idea of what we're going to get up to. So be thinking about communicating well, building models, checking your assumptions and conditions, and asking yourself, not are they different, but is the difference enough to statistically matter? That's where we're going. It'll be a fun adventure.